This week on Maker Update, Bowling 300 in your kitchen, Knights of the Canadian Tuxedo, a dimpled display, and a control board for tiny bots. Hello and welcome back to Maker Update, the show where we find all the coolest maker projects from across the internet and share them with you to hopefully inspire your next project. I'm Tyler Weingartner and I hope you're all doing great. We've got a super fun show for you, so let's get it going with the project of the week. One of my favorite things about going bowling is the just barely hidden symphony of mechanisms that play out every time you send a ball down the lane. The arms that pick up each standing pin, the bar that sweeps the other pins away, setting the pins back down in the right layout for the next play, and the ball return mechanism. It's like getting a glimpse behind the curtain of an elaborate clockwork. But so much of the inner workings are still hidden. But if you want to take a peek behind that curtain, look no further than this video by Danny Lum. Somehow I missed it when this video came out 2 months ago, but he's created an almost entirely 3D printed, completely functional tabletop bowling lane that fits on top of a kitchen table. It does everything you'd expect a bowling lane to do. It sets the pins, counts the ones you knock down with your 2-pound marble, clears the pins away, resets the remaining pins, returns the ball, and it even has pop-up gutter guards for novice bowlers. It should go without saying that this is an insane collection of mechanisms that need to work reliably, quickly, and in close quarters with other mechanisms without getting in each other's way and jamming up. He began with a blank slate to solve all the mechanical problems on his own, but as the project grew in popularity, folks started sharing behind-the-scenes footage of how a full-size bowling lane works so he could use that as a reference. As if the project wasn't complicated enough, he began getting requests for the 3D printing files, and figured he would monetize the project by releasing the files through Kickstarter. But selling the files meant that he felt responsible for how the design worked, not just in his home, but in those that paid real money for it, which meant he needed to redesign a whole lot of parts for higher levels of reliability and repeatability. But it's not just the mechanisms that sell the experience here. There's a computer vision-based system used for scoring, a scoreboard that's maintained on a separate monitor, some diffused NeoPixel strip with glowing animations for that late-night party bowling vibe, and what every bowling lane needs: cursed animations that play out every time a play is made. It's an incredible project, and a super fun video to tell the whole story. More projects. Have you ever been struck by an idea so weird you just needed to will it into reality? That's the story behind this denim-clad medieval knight by Miss Twisted. You heard that right. This is a full suit of plate armor finished in denim. The construction techniques used here are fairly straightforward. Each plate of armor is made from EVA foam and contact cement, and the denim is applied over the top and held in place with fabric glue. But the project really began to take on a life of its own once she looked past the blue of denim and realized how all the different textures and seams could bring some wild details into this design. Of course, there's a lot of consideration made on where to place the telltale back pocket, since everyone will know that's the butt part. If you can look past the whimsy, this video is also an excellent guide for how to make a full suit of costume armor. But why would you? Take all of this ridiculousness in. That's what it's there for. Over the past year or so, we've covered a number of Soiboi Soft's experiments using pneumatics. He's usually using the power of air pressure to create actuators for soft robotics. But this time around, he's going in a whole new direction: a pneumatic display. He's recently been experimenting with creating basic circuit blocks that use air pressure instead of electricity. And this is the culmination of that work: a multiplexed array of logic gates beneath a flexible membrane that can be pulled into a divot, creating a single pixel. Seeing the display in action is definitely the cool factor, but don't sleep on how he created these air-powered AND gates to make the multiplexing possible. There's another thin membrane between two rigid 3D printed pieces that only react when both inputs are active. There's just one catch, literally. While he can turn the individual pixels on, the mechanism latches each one so they can't be turned off individually, but rather all at once. But that doesn't keep this 4x4 grid of shiny, rubbery pixels from being absolutely mesmerizing to look at. And if you haven't had enough projects that you can see through, check out this translucent astromech by Swooshdave that he calls R2 See-Through. I might be mistaken here, but this is one of the first full-size, fully 3D printed R2-D2s that I've ever seen. He's using transparent filament, which gives the entire droid a sort of milky, not fully transparent quality. It's worth noting that this isn't your typical remote-controlled mechanical R2-D2. But with this coil of internal addressable LED lighting, it's more of a geeky floor lamp. But seeing all the external details of the astromech lit from within makes this project a sight to behold. Now for a few tips and tools. If you like building tiny robots, check out the CodeCell C6 drive by Microbots. On this board that's about the size of a quarter, you get an ESP32C6, a dual H-bridge motor driver, a light proximity sensor, a 9-axis IMU, and a battery charging circuit. It's a ton of functionality in a disarmingly tiny circuit for robotic and RC projects. It's no surprise that the founder of Microbots is none other than Carl Bujeha himself. The CodeCell C6 drive is available on the Microbots website and sells for €33. In a YouTube short on Salveo3D's channel, he shares his technique for reverse engineering any mechanical thread. CAD packages like Autodesk Fusion have modules for creating standard metric and imperial threads. But what if you're designing around something weirder, like the cap of a water bottle or the top of a painter's pole? As long as you can measure the outer diameter, the inner diameter, the thread pitch, and the number of revolutions, you have everything you need to design threaded parts that fit together tightly. It's good stuff. And from Paul Legier, we have a guide on how to design 3D printed parts for minimalist furniture you could use in your home. He has two goals in mind here. The 3D printed parts should not be obviously 3D printed. They should complement the wood and the overall design and structure. And all the parts should be printable on a consumer-grade printer. He's building a tripod-style end table where the legs fit into this top plate and then pass through this 3D printed coupler before extending down to the floor. No glue, no advanced joinery, just screws, and it's even strong enough to support his body weight. It's impressive stuff. For this week's DigiKey Spotlight, Becky Stern has the latest entry in her electronics teaching series, and it's all about how to build sound reactive projects. Whether you just want to animate some wearable LEDs that react to the beat of the music, you want to build your own flashy spectrum analyzer, or you want to control a project using the sound of your voice. Becky's video talks about all of the current tech at your disposal and which ones you should consider for your project. Check it out. All right, and that is going to do it for this week's show. A reminder, as always, that you can get more info about every single one of these projects by following the links down in the description. While you're there, leave us a comment, give us a thumbs up, and hit subscribe so you don't miss the next one. Huge thanks, as always, to DigiKey for making this show possible and to you for watching. Take care. We'll see you soon.